I searched it up and I was like,
The parabola just bounces stuff. So parabolic reflectors of the microphone at the focus light to listen to sounds from far away. A parabolic microphone is a reflector that's 22.4 inches in diameter at 8 inches deep. So whenever you're doing modeling, always create an XY coordinate plane. Always. 100%. Then what you want to do is draw the parabola. And how you draw it's up to you. Personally, I'd put the vertex at 0, 0 to make your life easier. You can put it wherever you want, but you're gonna make the problem more challenging. So I'd put the vertex at 0, 0. And it says 8 inches deep. So it means that this dot right here, and it's not going to go forever because obviously it has to end somewhere, right? So that's going to be at 8. And that's going to be at 11.2. How do I know that's 11.2? Yeah, so then this has to be at negative 11.2. Okay. Now, what's the equation of a parabola? I know it's x squared equals 4py, given the way I've drawn it, right? Now, they say the microphone is at its focus. So I don't know where it is exactly, the microphone. So I'll put like, say, I don't know, right here. I'm not 100% sure where it is right now. So what I need to do, opens to the right. Crap. Okay, let's say it's opening up for now. No, we should do it accurately. Darn it. Okay, I'll do it real fast. It's my OCD kicking in. Let's do it correctly. Here we go. Okay, there we go. That's at 8. That's at 11.2. And that's at negative 11.2. Okay. And the focus will be over here. Okay, so y squared equals 4px. Now, do I have a point that's on the parabola? What point could I use? Good, perfect. So you're going to plug in 11.2 for y and 8 for x and solve for p. And wherever that is, that's your p value. So I definitely need a calculator to do that. And that's how you write the equation. And then once you solve, actually, I would do part B before part A personally, right? Because you got to figure out what P is, and P is the focus. Divide by 32. So you should get 3.92 for P. So your equation is going to be y squared. And what's that times 4? That's 15.68. And there you go. Y squared equals 15.8 x. Hmm?
because I know it's the focus, but I didn't know like it's like the diameter of the microphone. Like I didn't know how big the microphone was or whatever. It was just like
No, you see the location. You're overthinking it. We see the location. That's all. Just where it is on the x-axis. That's all they're asking for. How far it is. Hmm?
oh,
No. This is 20. The width of this. You know, like a satellite dish. It's not like that. That's all it is. And then that's the 18. That's it. So don't overthink. You're overthinking it. Okay, so Lucas, you asked about which one?
Oh yeah, that's
Same one?
Yeah.
Oh, okay. How are you guys with 11 and 12? We're okay? Cool. All right. And 1 through 9, we're fine. How about completing the square? Or 2 and 7? Actually, number 2. Or writing the equation for number 7. We're okay with that? Sure. So even if you're not asked to graph it, I would graph it. Just so you can visualize what's happening. So negative 3, 4. 5, 4. Center's right here. Foci. Okay, crappy looking let's go with it. So our formula is going to look like this. And its major axis is horizontal. We want H and K, of course. That's your shifts. So you still have shifts here happening. So what will your H and K values be? How are we shifting it? Away from 0, 0. 1. Right. How far am I going from the center to either endpoint of the major axis? 4, so you can put 16 below. Now we'll worry about going up and down. Y minus 4 squared over blank. Now, what's your C value? Correct. And I'll give this formula, don't worry about it. C squared equals A squared minus B squared. So 4 equals 16 minus B squared. What's B squared going to equal? Yeah, you don't need to solve for B, just give that. And there you go. That's your equation. There's not much work to show, to be honest. But not far to put it. I recommend doing wrong. So if your drawing's off, if I see maybe you drew this incorrectly, then I say, oh, okay, I can see why your answer's off because I can see your drawing. But there's not much work to show. When it says right, it literally means that. Just write it down. There's not really much to show. Does that make sense? We're going to see some more problems for our next shape later today. Okay, anything else? All right, we got to move on. So let's move on to notes today. So notes today, we're going to start on page 13. We'll see how far we get. As long as I feel like we cover what hyperbola is. And do look at the shifts and maybe some word problems today. Actually, we're going to probably have some word problems for sure and some random stuff. The hyperbolas are quite analogous to ellipses. It's a pretty similar formula. Also, tomorrow, no, I don't see you guys tomorrow. No, Wednesday. We're gonna do Wednesday. We're gonna talk about how trig is related to all this. Excuse me, it's a little spicy here. Let me put this away. We're gonna talk about how trig is related to all this stuff, so we're gonna do that. And I figure you guys probably could use like 2 full days of review with this. So we'll have a review on Thursday. Next week is only 2 class meetings, just so you know, because of parent-teacher conferences. So we meet Monday, Wednesday next week. Our test is Wednesday next week. So we should have most new material done by Wednesday. Anything left over, we could do on Thursday. But I'll start the review then. You guys can use the weekend to review. And then we'll do more review. And I think what I want to do on Monday next week, sometimes I do go out into the hallway and like have students, like I'll put problems up and just kind of just put some crazy problems and have you guys just do it and watch you guys. Because I think that's good. I need to help you guys with, and if you get stuck, if I see like, oh my God, like that's that one step, you just can't get over that hump, I'm going to help you with that because I think you guys need a little coaching with that. Because that's what happens on these tests. Sometimes you guys can get stuck and stare at a problem for too long. We want to make sure that have the tools or the confidence to get over that. So we're going to do that kind of stuff on Monday next week also. So I decided to move the test an extra day. So, I think, and that's perfect because we start the fall break right afterwards. So that's awesome. I mean, it's only 3-day weekend. It's not really a break, but you get the idea. All right. Anyway, let's talk about hyperbolus. So from a conic or cone perspective, if you took like 2 cones, but if I went to like, Michael's or arts and crafts store, and like styrofoam cones, put it like this, and slice it down this way, you're going to form these 2 cross sections that look like 2 parabolas going against each other or away from each other. That's actually what we call a hyperbola. Okay, so it's a hyperbola. Almost spelled like hyperbole, but it's not English class. It's not an extreme exaggeration. There's no hyperbole here. No. It looks like something we exaggerated. We exaggerated the shape, but no, it's nothing with grammar or English class. Let me show you the derivation really fast. I think I already posted these to Schoology under lecture notes, so you can view them at your own leisure. If you're really bored over the weekend, you can. Not just kidding. and I'm not going to ask you guys to prove these, but just so you see what's happening, it's pretty darn close to the derivation for a ellipse. It's 3 pages, I believe. Yeah, it's kind of crazy. But it's kind of good that we kind of fixate on this image first, so you understand what's going on. But for me to go over all the crazy math is a little much, so I don't want to do that today. So remember what an ellipse was? It was a set of all points in which the sum of the distances from 2 fixed points is a constant. So remember we had an ellipse, we had an oval, and I took the rand point on the oval, and I had these 2 fixed points, and I had these 2 segments, and the 2 segments add up to the same number. In this case, these 2 segments, the difference, you subtract them, will always be the same number. So it's just the opposite. Instead of adding these 2, you subtract these 2. So d1 minus d2 is a constant. That's what's going to happen. So if I ever pick any point on this curve or that curve, and I have 2 foci, just like the parabolas, the foci are inside, and we'll still call the C, by the way, from the vertex to here, vertex to here, and from the center. This is the center of the hyperbola, and from E to vertex, called A. There's no B. There's a B value, but it's not really like a covertex. It doesn't really have that, but we still use it anyway. And actually, what's really happening, and we'll produce it when we do notes. What's really happening? There's an invisible rectangle. There's an invisible rectangle in the middle. This width is 2a. This height is 2b. So from here to here, that's b, and from here it's a. We'll talk about this when we do the examples in the notes. So there's a box here. There's actually, believe it or not, there are 2 asymptotes. There's slant asymptotes, and the graphs go along the contours of those asymptotes. So you need the rectangles like a foundation, and then you have the asymptotes to help guide the graph. That's how these graphs are done. But in order to prove why the equation of a hyperbola is what it is, it's all crazy math. I'm not going to go through it. Just trust me, it works. If you go through all the crazy math, you stumble upon, and then also understand this. And the c squared part, instead of being a squared minus b squared, it's a squared plus b squared. If we substitute that in, you stumble upon that. There's a derivation as a y. That's true. C squared equals a squared plus b squared. I don't want to do that today. But it's pretty much the same thing, but it's a minus. Emery, hold on to your question one sec. Because it's opening horizontally, and that's just going to answer your question. Because it's opening horizontally, you always put x squared first, and y squared will be negative. We call that the transverse axis, meaning the axis of, well, the y-axis still cuts it in half too, I suppose, but because it's opening left and right, or it's opening horizontally, put x squared first. You can reverse it and go up and down, then y squared is first and x squared is second. Just saying. Was that a question, Marie, or yeah, there's something else?
It's like for the D1 and D2, are you gonna have to like know anything about
No,
that?
no, because that's a little much. That's but maybe I might put as an extra credit. If you guys want, I could do that. You guys want some extra credit and memorize the derivation and do it on a test, I could do that.
Where is that?
Yeah. If you want to drive that, yeah, go for it. Yeah, it's there in Schoology now. You could go to YouTube and I closed my browser because my computer is really slow, but I'm pretty sure I put in Schoology. Laura, go. Yeah, that's another derivation which I don't want to get into. Kind of a little bit. I remember I had the derivation for actually. Let me see if it comes to me right away, I'll tell you. If not, then because I don't want to spend too long thinking about it. Because I'll be honest, I don't remember. But we wound up figuring that out. Why that made sense. I think what I did was, yeah, I used the covertex. It might be the same thing, actually. It might be with that invisible rectangle in the middle. You know, this might be good to do on Wednesday when I feel like I'm not as rushed. Yeah. Hold on to that. Okay. Okay, now let's actually do an example from the notes. All right. So here's hyperbola, right? So it's x minus 1 squared, y plus 3 squared, over 4 squared over 2 squared. So here's what's happening. There's really not much. To turn the chord to the vertices, got it. Okay. Oh, where's my tools? Here we go. Yeah, so here's what's happening. It's not terribly obvious, but your center is right here. How far is it from the center to either vertex? I'm sorry, say again? 4, good. And how far do I want to go up and down? 2. And you draw an invisible rectangle as like your base. And by the way, look at those asymptotes. Okay, I almost did it perfectly. So see how like the diagonals of the rectangle, right? The diagonals of the rectangle. Okay. Actually, that's a good looking rectangle. All right. So what are my vertices? My vertices are 5, -3 and -3, -3. That makes sense? We're good with that? Now the asymptotes. How would I write the asymptotes for this? It's pretty clear the asymptotes are both passing through the center. And the slopes, if you just think about it, how far do I go up and over? I go up 2 over 4, but the other one's down 2 over 4. Here's how you could write this in a very concise way and fast without driving yourself crazy. Because if you want to write this in point slope form, sorry, slope intercept form, good luck. Don't do slope intercept form. Do point slope form. Because if you do slope intercept form, find out y-intercept's going to be a little tricky. It looks like it's a weird decimal. I don't want to deal with that. So here's what I'd say. I'd say y plus 3 equals plus or minus 1/2 x minus 1. Done. That's part B. I got it in like 5 seconds. How do I do it? I mu is fast to the center, in 3. So that's my x1, y1 is point slope formula. My slope will just look at it, up 2 over 4, down 2 over 4, it's 1/2. But there's a positive and negative counterpart, so I consolidate it as 1 called plus minus 1/2. Okay? So you have that. So that's the asymptote, and that helps guide the graph, as you can see. Helps guide the graph. So that's kind of the anatomy of a hyperbola. Okay. So far, we're okay? All right, let's look at number 2. So it says here, so we're going to try something a little different. Okay, we're going to draw a new one. Now, y is positive and x is negative, right? The fraction involves y is a positive fraction. So first of all, let's get my center. Where's my center? 1, -3. Okay, oh, well, same place, all right. And I have to go 2 up. And it's a little tricky because sometimes we write like this, y plus 3 squared. Actually, be mindful of how it's drawn. I prefer to write it like what I did above. It's the same thing, obviously, right? If you square this, you get that. It's the same thing. But you're going to go 2 up, 2 down. 4 left, 4 right. 2 up, 2 down. Actually, it's the same as before. Is that crazy? Okay. Well, not really crazy. It looks good. No, great question. So A always goes with the positive fraction. Actually, thank you for bringing that up. A always goes with the positive fraction. So before A was a bigger number for ellipse, so different than ellipse. Thank you. I forgot to mention that. Different than ellipse. Because for an ellipse, A was for the major and B was for the minor. Here, A is for the positive fraction. And I'm going to draw my asymptotes. Oh, that's pretty good, actually. Okay. But now you got to do this up and down because y is positive. Okay.
So why is positive?
It's vertical. The fraction. The fraction. Fraction positive. That fraction negative. This is a minus in front of it. And I will give you, so on the formula sheet that you'll have, because I really don't want to make this about memorization. That's kind of dumb. It'll look like this, I think. Yeah. So you'll have that anyway. Like I will literally give you this. Vertical axis, there you go. Horizontal, there you go. This one, yeah, I did say horizontal is a squared. Yeah. Yeah. Okay. And I give you like the parts on the cosine. So
When you say that, like,
Mhm.
A always goes with the positive fraction,
Mhm.
so for this question, that means that A is 2.
correct. Right.
So A isn't always like just the horizontal one.
Nope. Actually, and I was wrong in saying that for the ellipse because A should really be the bigger, but it doesn't really matter because when you graph it, you're just gonna go when you graph anything horizontal, you're always gonna go left and right depending on what's below X. And you're always gonna go up and down depending on what's below Y. Where it will matter is when you solve for C, but the thing is that like you're not gonna do a small number minus a bigger number having C squared. So you know A has the bigger number. Here it's actually immaterial. Whatever's A and B pairs. You add it. So it doesn't really matter. That's kind of it's not really anything we should be concerned about. Okay. I don't know if we should do. Let's actually jump to number 4 because I want to find the foci. Yeah, 3 and 4 are kind of similar. Let's do 4. And I'm going to talk about 5 briefly, and then we'll do some. Then we'll get crazy. We'll do some crazy stuff because crazy is good.
Wait, do we get to make the Olympic rings?
Sure, why not? Okay. Actually, no, we don't have time for that. No, we're not going to. That would be neat, though. Actually, when I taught to 2 trigonometers, when we had more time before the pandemic, and seriously, when the pandemic happened, like then all of a sudden we just lost all this class time. But we used to do a project. We had to create I call it the conic creature project. You actually had to like make a like an alien creature or anything crazy using conic sections. It was actually a pretty cool project. I don't know if we have the time for that. If I could find some, there's some really cool ones from like 15 years ago, where you'd use like all these different shapes and then right around the time frames, like right when the Giants were playing well and the Sharks were playing well, we got a lot of various sports teams. So people do like a lot of sports stuff just to appease me. So that's kind of nice too. But yeah, there's some really cool stuff that some students did. Um, but anyhow, but no, Desmos, you could do some cool stuff too. All right, let's look at form 4. I'm gonna divide everything by 48. Okay. Let's divide everything by 48. So you should have this. And what do you have on the bottom of this one here? Yeah. That's a little nuts. So 5, 4 is over here. Move that. Here we go. Okay. So we have to go how far left and how far right, guys? Good. How far up and down roughly? 2 point something. Yeah. Okay, make your invisible rectangle. And I went a little too far with the far left point. It should have been over here. My apologies. Okay, let's do this next. Okay, we're opening horizontally. That makes sense, the graph? Yeah, okay, cool. So good. Again, find the center, figure out A and B, go up, down, left, right appropriately, draw your rectangle, draw your diagonals, draw the curve. Make sure you open it correctly, left, right, not up, down, because X is positive. Okay, V, F, and asymptotes. We call these the important characteristics of the graph. Now the vertices should be pretty easy. That's 1, 4 and 9, 4. You guys agree? Okay, the foci. C squared equals A squared plus B squared. What's A squared plus B squared? So C is plus or minus. And it's going to be on the transverse axis. I'm just kind of haphazardly drawing it there. I don't know exactly where it is. Well, I do know exactly, but I'm getting lazy. So, but you're going root 22 left, right, or up, down? Left, right. Thank you. Yeah, left, right. So you want to go 5 plus or minus root 22. Actually, I did go a little bit too far to the left. It's okay. Because root 22 is roughly what? Yeah, it's not quite 5. So I should have gone over here, actually. I was haphazard about it. Yeah, kind of like right there. Okay, cool. And remember, the whole definition of it is like if I pick a random point here and drew that segment, that difference between those two segments must always be the same. If I pick another point elsewhere, like say over here or say over here, the difference between those two segments must always be the same. That's the whole definition of it. Lastly, the asymptotes. I'm going to say y minus 4 equals plus or minus. And again, there are formulas that people can memorize. Oh, you should always do A over B or B over A, whatever. Nonsense. Just look at it. How far are you going up? How far are you going over? Done. There you go. So plus minus root 6 over 4, because you know it's a positive and negative, and x minus 5. You guys could totally handle that. Just trust me, if you try to like memorize that stuff, you go crazy. I don't want you guys to go crazy. I want you guys just to look at it and know what to do. If I do show you a more detailed formula sheet, which I think I might have maybe here. This is not provided on the test, by the way. This is what we get. So I've taught at level precalculus, which is 2 levels below this class. We give them all this crap. I say crap because actually I think it hurts our students. Because I remember I was like, I taught this class 2 years ago. I was like, how are you guys messing this up? I gave you everything. Like, I don't know what's H and K and C, and they get all crazy and like which was it, A or B, B or A, and they get all messed up. Like, honestly, I think that's worse. I think just simple is better. So, kind of like Mount So, be humble, be simple, you have joy. So there we go. Okay. So anyhow, yeah, you don't really need all that stuff. I think just what it provides, and just look at it. Does that make sense how this works? Okay, cool. Last thing, then I want to show you some crazy problems. And we'll do some of the stuff in the following pages. Now there's a if you guys ever like if you look this up online, if you work with a tutor or anyone else, there's actually a classification system. Like A is the coefficient of x squared, and you have C in front of y squared, you have B and D, and you have F and B. And there's a crazy classification system. Like, don't worry, I'm not going to do anything with X, Y together. That's crazy. I'm not going to do that to you guys. That's kind of nuts. But there's a classification system like, oh, if like A plus B equals this, or A squared plus B squared. I don't remember it. and use that to help you classify. I think that's, again, that's nonsense. I think what you need to do when you're trying to classify, if I give you something like this, you're like, oh, I don't know which one it is. Seriously, so here's what you do. Are both x and y squared? If no, parabola. Are both x squared y squared the same sign? If no, hyperbola. This is a flow chart, by the way. Do x squared and y squared have the same coefficient? If yes, circle. Otherwise, ellipse. That's really it. So if x, y are both squared, then it could be circle, ellipse, or hyperbola. But if they're not, then it has to be a parabola, because a parabola only has one square term, right? We know that. Okay, let's say they're both squared. Okay, fine. Are they the same sign? Because if one's positive, one's negative, then it's got to be hyperbola. I'm done. But let's say they're both the same sign, both positive, both negative. Okay. Do they have the same coefficient? Then it's got to be a circle. And we divide it by that number. So if yes, circle, and then otherwise your last option is an ellipse. So now we look at this. Part A. What's part A going to be? What's part B going to be? Yeah, I think, yeah. Oh, part C. Great. The process elimination, but part D. There you go. Yeah. That's really the best way to do it. Again, there's this wacky formula you can use these A, B, C, D, E, F things. That's just nonsense. Circle, ellipse, parabola, hyperbola. And then when you're asked to complete the square, because I will ask you to complete the square for these. When you complete the square, hold on, Ken. When you ask to complete the square, then you know what you're getting yourself into. Then you know, oh, okay, I'm doing the hyperbola. I gotta make it look like this formula. Okay. Now we gotta find like the characteristic, whether it's the foci, asymptotes, or whatever, or co-verses, verses, and then you can go about graphing. Okay, what's your question?
Because they both have the same positive sign in the
Mhm.
square.
No. They have to have opposite sign to be
Oh, sorry, yeah.
yeah, they're both positive. I can make both a negative, it still would be an ellipse. Yeah. Once you move everything to the other side, or multiply by -1 to both sides. Yeah, because if you multiply both sides by -1, you can get positive. All right. Let's do this. We're not gonna do the Olympic ring, sorry. That's a more fun one. Okay, let's do 2 and 3. For two, so for 2, what do you expect this to be? Circle. How about for this one? Parabola. Yes. Okay. Let's do it. Actually, you know what? While I'm at it, let me print the formula sheet for you guys, so you guys have it as a reference. Let me do it right now. I think that'd be a good idea. We'll be right back. Let's do 15 of them. There we go. Don't leave behind a white calculator here on Friday. It's really nice. Well, I'll use it in the meantime. All right, that's nice.
Wait, it's not, this means -1, -2. That means 1.
All right, well, the machine's preoccupied, so we'll sort out the form sheet later.
Alright.
Yes, it's square. No, it's a whole lot.
Hey, mind you, I am doing this in my head, which is not the best idea. But you're not me. Okay. Do you guys get that?
Yes, it's square.
Yes, no? Yes? Okay, cool. So graph should look like this. Yes? Cool. I probably won't give you one that easy, but let me show you one of my old tests, because what I have done before. We are starting tomorrow, not tomorrow, sorry, Wednesday. I'm gonna ask you to graph multiple conic sections on the same coordinate plane and find me where they touch. We're gonna do points of intersection. Um, which will involve solving a system of nonlinear equations, which involves some substitution, elimination, and using the graph to verify. But I could ask you to do this with another graph on top of it. Sure, I could do that. This one here, y minus 2 squared equals 2 parentheses x minus 2. Yes or no? I could be wrong. Hold on. Okay. If I complete square, y squared minus 4y plus 4 equals 2x plus. Is that right? Okay, I was wrong. Is it x minus 1? Yeah, I was wrong initially. Okay. So 1, 2. Which way you don't do in your head? How's it open, guys? Left, right, or up, down? Sorry, left or right or up or down. One of those four. It's going to go into the right. And the foci would be, actually, we don't need to really worry about the foci so much, but if I do plug in, if I plug in 2 for, no, that'd be weird. If I plug in 3 for x, if I make a little table, I know 1, 2 is a point. If x is 3, that makes the other side 4. So y would have to be 4 or 0, I think. Yeah. Okay. So that's okay. You guys are cool with the graph there? Okay. All right.
Wait, in that form is,
Hmm?
is 1, 2 just directly below for x?
Correct. And my 4p equals 2. So my p equals 1/2.
Wait, isn't that 4 p? Wait. Wait,
That helps you find the focus in directrix. So my focus, by the way, would be 1.5, comma 2. And my directrix would be x equals 0.5.
where's the standard form of a proper living for concept?
It's right here. Y minus k squared. That's for one that opens left to right or horizontally.
And then if it was
Switch x and y. Yep. And make sure you put the h next to x and the k next to y. So you can simmer on this a little bit.
You do. Like,
Oh, that's just, I just got a little more ambitious. I wanted to find the important characteristics like the focus and the directrix. Yeah, because part of the formula, correct, right. There's also some other terminology which I don't want to get into today. I can say that for Wednesday. There's a term called, it's kind of a funny term. It's called lattice rectum. if you do work with a tutor or look online, it's a property of the parabola. And I'll be honest, I don't remember it fully myself right now. I have to look it up. But I think you would go out 2 this way and 2 up. I think it helps you find that distance. I think that's what it is. But we'll worry about that later. There's also another term called eccentricity. Again, I'm going to talk about that stuff later. Oh, there was mention Russian math? Might have. Okay. Okay. All right. Okay, let's do crazy. Let's see here. Oh, thank you, Ms. Pagano. Appreciate it. Good. Thank you. Okay, this is a form issues, but I also have to come in half, so I'll do that later. Let's see here. Let's do this. Why don't you guys try number 10 on page 18. So this is a hyperbola. Okay, but you gotta complete the square. So I'll make sure you guys are comfortable completing the square here. So go and try 10 on page 18. And also I want you to state for me the vertices, the foci, and the asymptotes. It's not crazy yet. Absolutely will be crazy. Oh, the center too. Give me the center. By the way, how's this going to open horizontally or vertically? How's this open, guys? Thank you, Troy. Horizontal, yes. Because x squared is positive. Correct. Correct. Now, you could have moved everything over to the other side, but if you had done that, you still would have been divided by -4. You still would have it. It still would be x squared is positive. But yeah.
I know. Wait, do I get it? I think this is really important. No, I have to just be positive. Okay, the B can be 92 later. I don't remember any of that. Sorry.
Don't worry, it's okay.
That over the summer. Really? Started like like.
Huh? Oh,
Those were records, yeah.
well, no, not my side.
Just started. Wait.
She's actually squared.
Correction?
Yeah, not four, it's also squared.
So you've done for the matter.
Yeah, I need to open shape those tables.
So eight is two.
I think you want to open horizontal and vertically. Which one is over? Why is it over? Oh, so y and then which one's constant, so. Oh, wait. So then you can.
Shoots.
Right, left, because X.
Yes, go right, left. Correct. Okay, make sure you guys are on the right path. Oh, I'm actually doing this live with you guys. Never mind.
Okay, so we're gonna.
This feels great. Like, why it's on my alarm, like, if you even care, just for this day out. Are you serious? No, I'm not laughing. I'm not kidding. She's like, it's the refs, honey, it's the refs. Something's wrong, chill.
I think we should get that.
Only involved in. Sometimes I wasn't, yeah, the only child left, but I need to start. Oh, I have to, I provided them. We took this. Okay.
There's also what I'm seeing at the ad from.
Okay, I think I did it right. You guys agree? Got it?
Sorry.
My foci are good. Yeah, okay, cool. All right. So you guys got the foundation, which is good. I'm happy. I think now we can talk crazy. Now let's talk crazy. Let me show what I've done in the past. We got about 5 minutes. This is good. We could simmer on crazy for till lunchtime. Oh, are you guys still copying? Sorry about that. Anyone still getting this down? Yeah, I'll freeze the screen while I pull crazy. Okay. All right. What do we got here? Ooh, maybe that one.
I need to like 20.
Oh yeah, that's what I'm talking about. Okay. Yes, Lucas.
Focus 0. Isn't 0 minus?
You see? Maybe I could be wrong.
Wait.
No, because you're going root 20 away from the center. Yeah. Yeah. Okay. All right. So this is a problem I've given in the past. Okay. I tell you got right. That was a smiles. Number 7. Yeah. So I asked you to write the equation of hyperbola. The C over A ratio. So C is the distance from the center to the focus. A is the distance from the center to the vertex. The ratio is 1.25, meaning you can do 5 and 4 if you wanted to. A C can be 5, A can be 4, I suppose. No x-intercepts. So if no x-intercepts, then guaranteed this is opening vertically horizontally. Good, yeah. So opening horizontally, you'd have to touch at least twice, right? So it's not area of the central angle is 48. And the course of the bottom right corner is 2, -6. So you have to kind of like, so it's not easy to tell like all the steps right from the beginning. So you kind of just say, well, let me just start with 2, -6. And if you think about the central rectangle, what are the dimensions of that? Since it's opening up, down, I'll call this 2A and 2B. So wouldn't 4AB equal 48? And AB equals 12. See, that's what you got to do. You got to just take that chance. Like, even though you don't know what to do with it, just write it down. Get it down right away. You can't, but if it's open left, right, guaranteed you have x-intercepts. Guaranteed it would. So it's got to be so it's got to look like this: y squared over a squared. There's also an h and k too. Actually, let me write it more properly. Yeah, kind of ran out of space here, but whatever. Okay, C over A equals 1.25. So C would equal 5/4 A. Okay. So you could do a substitution here. Okay. You have 2, -6. Oh, was be equal. Okay. Guess where I'm doing with this now? 25a squared over 16.
Could you also just think about numbers that?
Six.
You can, yes, you can, like look at the check like that. That might make, yeah, like integers that multiply to 12, sure, like 3 and 4, maybe 2
Yeah.
and 6. Sure, you could do that. And then, but you need to make sure it verifies everything. But you can see, at least I'm taking a leap of faith, like, okay, cool. I got this, I got this. Well, it's not leap of faith, I have faith in this, I know it's happened. Because then I gotta solve for it, but you can see, at least by plugging in, I have a plan of attack. So I'm not staring at the problem blankly, I'm actually like, oh, let's actually go through the motions here. And start solving this. So anyhow, I'm not gonna, because Bill's gonna ring about a minute, but this just gives you an idea of what crazy looks like a little bit. We're gonna practice this on Wednesday for sure and Thursday. Homework, I'll go to schools, I'll put it up there. But see, this is a problem where you take your foundation and we expand on it. That's what we're gonna try to do. Okay. I would not ask this out of any group except you guys, because you guys can handle it. So